Hey guys, this is CHEMPLIFIED and today we will talk about Mesomeric Effect. This is in the series of inductive effect. This is the second part, Mesomeric Effect, and third part will be electromeric effect. So let's start with the definition of Mesomeric Effect. The definition of Mesomeric Effect will be like this. The Mesomeric Effect or M effect refers to the polarity produced in a molecule as a result of interaction between two pi bonds or a pi bond and a lone pair of electron. Now, in this particular definition, there are a few things that must be considered. First one is polarity. Second one is interaction. Interaction between two pi bonds or a pi bond and a lone pair of electron. The first thing is polarity and second is interaction. Interaction can be of two types, between two pi bonds or a pi bond and a lone pair of electron, right? Now there are similarities between inductive effect and mesomeric effect. One of them is the effect is transmitted along the chain in a similar way as are inductive effects. Just like inductive effect, mesomeric effect is also transmitted along the chain. First, we will try to understand the term polarity and interaction in terms of mesomeric effect, right? So let's go for polarity and interaction. Polarity simply means creation of positive and negative charge in a molecule. Let us consider a simple example. When a pair of electron gets transferred, this molecule is in conjugation. So the pi bond will get transferred from this place to this place, and then this pair of electron will move to this carbon, and the final formation will be like this, and creation of delta positive charge and delta negative charge. Or in this case, since we know that there is complete transfer of electron as compared to that of inductive effect, so we can simply write positive and negative charge. So this carbon will be positively charged and this carbon will be negatively charged. Again, due to resonance, this will transfer back to these positions. So in this particular case, polarity is created between first carbon and last carbon with a positive and negative charge. Now we will talk about interaction. Now there are two types of interactions. First one was interaction between two pi bonds. So there are two pi bonds. We have already discussed this example. The electron will be transferred in this manner and positive and negative charge will be created on first and last carbon. Second type of interaction was between lone pair of electron. This is your lone pair of electron and this is also your lone pair of electron. So interaction was between lone pair of electron and pi bond. This is your pi bond. In this case, the transfer of electron will take place like this, and positive and negative charge will be created as, or can be seen as, the carbon will have negative charge and oxygen will have positive charge. Here is your polarity created due to the transfer of electron. So this is your polarity and interaction. Now we will move ahead in the topic mesomeric effect. Now we have types of mesomeric effect. How many types of mesomeric effect are there? Two types. First one is minus M effect and second one is plus M effect. The definitions of minus M and plus M effect will be very much similar to that of inductive effect. Let's see. Minus M effect. Atoms or groups which draws electrons away from carbon atom are said to have -m effect. Those atoms which draws the electrons away from carbon atom will show -m effect. Example of these kinds of groups are NO2, CN, CO. These are the groups which are electron acceptor. They will accept electron from carbon atom and draws the electron towards themselves. So they will show -m effect. Now next is plus m effect is very much opposite to that of -m effect. So atoms or groups which lose electron towards the carbon atom are said to have plus m effect. Those groups which can donate a pair of electron towards the carbon atom, not to the carbon atom, towards the carbon atom, will show plus m effect. Example of such groups are, examples will be chlorine, bromine, iodine, NH2, Nr2, OH, OCH3. These are the groups that will donate pair of electron towards carbon. Now fluorine is not there, chlorine is there, bromine is there, iodine is there, but fluorine is not there. Why? Because first reason, fluorine is of very small size and fluorine is highly electronegativity. Fluorine is highly electronegative and will not allow its electron to go towards any other atom. Alright, so that's why fluorine is not there in case of mesomeric effect. In inductive effect, chlorine, bromine and iodine were there in -I effect, were showing -I effect, but in case of mesomeric effect these will show plus m effect because they also have lone pair of electron that can be donated, right? They have lone pair of electron that can be donated easily. So remember this particular difference. Last but not least, more to know about mesomeric effect. So first thing is mesomeric effect is permanent. Mesomeric effect will be there until and unless there is some outside force that will change the consequences. Positive and negative charge will be there. They will change again and again due to resonance, but they will be there because of mesomeric effect. Second is mesomeric effect indicates charge distribution in a molecule. Yes, there is a creation of positive and negative charge. Right? Like this. So mesomeric effect indicates distribution of charge in a molecule. Third one, mesomeric effect is of great importance for conjugated compounds. What are conjugated compounds? Alternate single bond and double bond. Like this. Alternate single bond and double bond. In case of benzene, benzene is also a conjugated compound because there are alternate single bond and double bond. In case of conjugated compounds, mesomeric effect definitely plays a great role and it helps us to determine various resonating structures for that particular compound. Alright. This will be it for today's video. Thank you very much. In the next video, we will go for electromeric effect.